All right, in this video, we're going to use page 60, problem number 2, to go through production possibilities and opportunity costs, comparative absolute advantage, what we mainly did in the last video, or the concepts that we covered in the last video. So we're going to read through this problem, read through all of it, and then we will work through it as we go. So it says, American and Japanese workers can each produce 4 cars a year. An American worker can produce 10 tons of grain a year, whereas a Japanese worker can produce 5 tons of grain a year. To keep things simple, assume that each country has 100 million workers. For this situation, construct a table analogous to table in figure 1. We're just going to make a table that shows how much they can produce. B says graph the production possibilities frontiers for the American and Japanese economies. C, for the United States, what is the opportunity cost of a car of grain? For Japan, same thing. Which country has an absolute advantage in producing cars? Grain. Which country has a comparative advantage in producing cars? Or grain. Without trade, half of each country's workers produce cars and half produce grain. What quantities of cars and grain does each country produce? Starting from a position without trade, give an example in which trade makes each country better off. All right, so we'll work this problem together. So first what we're going to do is we're going to start making this table. So we're going to say that this is the U.S. and this is Japan. And they each have the ability to make these 2 types of goods. So we're going to kind of figure out some details with these goods. So we'll call this first good, we'll say is grain. And the second good we'll call, what was it again? Oh, it was cars. But we'll do cars over here. That's fine. So we have cars and grain and cars. So each country has 100 million workers. So we're just going to talk in terms of millions. So everything you can just assume is in millions. And then it tells us that American and Japanese workers can each produce 4 cars a year, and we have 100 million workers. So the U.S. Can produce 400 million cars, and Japan can produce 400 million cars because each of them has 100 million workers. If all those workers were producing cars, they could produce 4 cars for each worker, 400 million, 400 million. Got it. All right, what about grain? It says an American worker can produce 10 tons of grain a year. All right, so 100 million workers times the 10 tons of grain is going to be 1,000 million or a billion, but we'll just call it 1,000. So for the U.S., we're going to put 1,000 over here, which is how much grain they can produce, whereas a Japanese worker can only produce half as much. And so they can only produce 5 tons of grain a year. So we're going to say this is 500 over here. All right. So we made a table. Got it. And it's in output terms. And so the U.S. can produce with those 100 million workers 1,000 million tons of grain, 400 million cars, or 400 million cars. And Japan could produce 500 million tons of grain or 400 million cars. So graph the production possibilities frontiers for the American and Japanese economies. Okay, so this next bit, we're going to graph production possibilities for each one of these 2. So we're going to call this, we'll call this grain here, and we'll call this cars down here. And for the U.S., should look something like this. We'll call this 1,000 and that 400. So this is 1,000. And this is 400 cars, right? So the most they can produce in grain is 1,000, and then for cars is 400, so we'll call that one the U.S. And then for Japan, remember it's going to start at like 500, so we'll call that 500 right there, but also ends at 400, so it's going to look something like that. So this is going to be Japan. All right, and that's their production possibilities frontier. Good. Next. For the United States, what is the opportunity cost of a car of grain for Japan? All right, so this is where we go about going like this. We say, okay, well, what does 1 grain cost me in terms of a car? what does one grain here cost me in terms of a car? And what does one car here cost me in terms of grain? And what does one car here cost me in terms of grain? So since this is now looking at an output question, the other number goes over when we're calculating. So OOO is our little acronym to remember how to calculate this problem. So let's look at it like this. Okay, so if I were to produce one grain of these, how many of these can I not produce? Do you think it's more or less than one? All right, so if I produce one of these, am I going to have to give up more or less than one car? Right? So think about that for just a moment. Okay, so in calculating these, the other number goes over. Right, the other number goes over. So 400 over 1,000, we're going to say is, we'll just call it decimal point 4. So it's going to be less than one car. So whether it's greater than or less than one doesn't really matter, but we want to know what's the opportunity cost. So one grain costs them 0.4 cars. All right, well, what about the other way around? So in this side, what we're going to see is that we take 1,000 over 400. And what we're going to notice there is that we get 2.5. So 2.5 grain. So for every one car they make, they could have made 2.5 tons of grain. And now what we can do is we can calculate it for Japan. And so for Japan, remember, other number goes over. So here, this one's going to be 0.8, right? Because you take 4 over 5, which is going to be 0.8. And so for every 1 ton of grain, they could have made 0.8 cars. And then for one car, they could have made 5 over 4 equals 1.25. 1.25 grain. And now we've calculated our opportunity cost for each one. All right, next one. Which country has an absolute advantage in producing cars and producing grain? So absolute advantage is just who can produce more. So we'll do absolute advantage in, I don't know, blue. So absolute advantage looks like this. So if I am looking at the U.S., and the U.S. can produce 1,000 versus 500, the U.S. can produce more. That's it. They can produce more. So the U.S. has an absolute advantage in producing grain. What about cars? Well, in this example, actually, nobody has an absolute advantage in producing cars because they each can produce 400. So that one, we're going to say nobody has an absolute advantage. But in this right here, U.S. will say absolute advantage, AA, just like that. All right, next one we're going to do is look at who's got a comparative advantage in producing each one of these. Well, in that sort of context, we look at who's got the lowest opportunity cost when it comes to producing all of these other things, right? So who's got the lowest opportunity cost when it comes to producing grain? Well, the U.S. has the 0.4 compared to the 0.8 of Japan. So the U.S. has a comparative advantage in producing grain. And then we look at who has the lowest opportunity cost in producing cars. We can see that that is going to be Japan. And the reason is because, they don't have to give up as much grain, right? They don't have to give up as much grain because the U.S. is really good at producing grain, which means when they don't produce grain, they give up a lot of it in order to produce a car, right? They give up a lot of it. So you can think about it in terms of this. Remember, each of them can produce 400 cars if they put all their resources into that. So what did the U.S. not produce because they produced the 400 cars? They don't produce 1,000 tons of grain. That's a big opportunity cost. In one, a single term, it's one car costs 2.5 grain, right? Or you could say 400 cars cost 1,000. How much does 400 cars cost them? Only 500. So they only have to give up 500 grain in order to get those 400 cars. So what would we rather give up, 500 or 1,000? We'd rather give up 500. And that is these terms right here. So one car only costs 1.25 grain. That's the lower opportunity cost. So we're going to say that is the comparative advantage when it comes to producing cars. So comparative advantage goes to Japan. All right. So the next part is, if we took half of our workers and dedicated them to production of each one of the two goods, how much of the two goods could we have? So for the U.S., you take half of your workers, you take 50 of your workers, and you produce one good. You produce, let's say, grain. They can produce 500 units of grain or 500 tons of grain. Or we'll say this is grain. Or they could produce 200 cars. And for Japan, they could produce 250 grain, or they could produce 200 cars, right? And they could produce 500 and 200. They could produce 250 and 200. Remember, because we have half of our workers. We have 50 workers here, 50 workers here. We have 50 workers here, 50 workers here. And so those are ands, not ors. Okay. Let's see, last one. Starting from a position without trade, give an example in which trade makes each country better off. So without trade, what we're going to do is say that they've got 500 here and 200 here. They've got 250 here and 200 here. So what could they trade for? So we're going to figure out this one. Let's see if we can give some more space here. There we go. All right. We want to be able to trade. What the U.S. is going to trade is they're going to give up some grain in order to gain some cars. Because Japan can produce cars cheaper than the United States can. So let's actually say they decided to produce no goods that they're not, that they don't have a comparative advantage in. So what we're going to say is the U.S. has 1,000 grain, and Japan has 400 cars. What should they trade for? Well, what they could trade for is something that is better than what they have to give up themselves. Let me say it like that. They have to trade for something better than what they have to give up themselves. So when the United States produces grain, they have to give up 0.4 cars, right? When they produce a grain, they have to give up 0.4 cars, or they could get 0.4 cars, right? And when Japan produces grain, they have to give up 0.8 cars, right? So if Japan were to produce, if they were to say, okay, we're gonna change this to 399.2, they could have one grain themselves, right? If they did it themselves. But what we have to keep in mind is you have the U.S. over here, and it only costs the U.S. 0.4. It only costs them 0.4 cars in order to make their grain. So they might be willing to give up one whole grain for something such as, let's say, 0.5 cars, because that's better than the 0.4 that it costs for themselves, right? So what if they were to say, no, don't do that yourself and don't do this and lose 0.8. Tell you what, give us half a car, we'll give you a grain, right? Give us half a car, right? So the Japan says, okay, I'll give you half a car. So they're at 399.5, right? They're at 399.5. They give them 0.5 of a car, and they gain their grain, right? So which option is better? 399.2 and 1, or 399.5 and 1? Well, obviously 399.5 and 1 is going to be better. So they're making a trade in between these 2 points. If it makes more sense, you could say 10 grain to 4 cars and 10 grain to 8 cars. So something in between this. This is how much it costs Japan to do it themselves. This is how much it costs the U.S. to do it themselves. So if they agree upon something in between there, let's say 10 grain to 6 cars, they're going to both be better off. They're going to both be better off because Japan only has to give up 6 instead of 8. and the US gains 6 instead of 4. Fantastic. They're both better off. They're both good. Or you could look at it in terms of cars, right? One car costs the US 2.5 grain, or one car costs Japan 1.25 grain. So you're going to look for something in between these two, which might be one car to, let's say, 1.5 grain, which if we kind of, multiply that out, it might be something like 10 cars to 15 grain. Something like that might work out for the two. And they would both be happy. They would both be better off.